Myself, Sunil Kothari, I head the business for South Asia market for energy Exemplar, being with the company 3 years in energy market from last 22 years. Uh, Today's discussion is all about talking about how the advanced energy modeling will help you to do the techno-economic analysis of, let's say, energy modeling, or especially since everybody's talking on the green hydrogen. So I'll talk about how advanced energy modeling will help you to get the right decision making and reducing your risk in the business, especially on the hydrogen, and the hydrogen derivative can be ammonia. It can be any green fuel. Just about the company, taking the opportunities to introduce company Energy Exemplar. I think it's been 25 years of this company, based in Australia, from South Australia, Adelaide. Almost 600 employees, more than 600 companies globally uses us our tool called Plexos. I think we have presence kind of many of the countries. You can see 80 plus countries. Just to India, we started India Excellence Center in 2017, around 200 people in India, 1/3 population of company sits in India. All the software developments, the modeling developments and support happened from our Pune and Bangalore office. We started commercial operation in India 2 years, 2.5 years back. More than 20, 30 companies started using Plexus, is getting benefited. Few names you can see on the screen. We'll be in regular touch with the government companies, governments, Grid India, CEA, many state utilities company to help them to going toward the energy transition. Energy Exemplar supports the complete ecosystem of the, I can say, the energy. We help regulators, we help governments, we help utilities, we help oil and gas companies. Many consulting companies also use Plexos to help many end users to get the right decision in their multi-million dollar, multi-billion dollar decisions when they are investing a lot of money in green hydrogen projects or many power and renewables projects going forward. Just to talk about the green hydrogen, that's why we are here today. Why green hydrogen? Why we are talking about the green hydrogen? Definitely, everybody's talking about moving toward the decarbonization. Hydrogen being a fuel can be a very good fit in the future scenarios. And as India is going very big way on the renewable side, even the globally many countries are going renewable, the big side, but renewable comes with its own challenges. You don't have the solar shining every time of the day. You don't have the wind blowing every time of the day. So it comes with its own intermittency. That intermittency can be held by the hydrogen as a fuel, which can be started with, can be maybe the hard to abate decarbonization industry, cement, fertilizer, steel. So that's the way world is moving. And hydrogen is a very good product to bridge the gap between power and gas. So globally, if you see the power markets and gas market using hydrogen from the different perspective. If I talk about the power market, the European power market see the key value in the hydrogen as the most commercially ready and scalable technology for energy storage to essentially synchronize the unpredictable intermittency that comes with the high grid penetration of the renewables. It is also allowed electrons to be stored and grid placed to manage the market in more stable form, for instances, peak shaving activities and maximization of the operations rates of load percentage. On the gas side, hydrogen basically take over the mantle of the the fumable physical fuel, which can be relatively easily be incorporated in the today's existing gas value chain and infrastructure. It serves the role of reducing emission in the hard to abate sector, which I told about, the steel sector, cement sector, and the fertilizer sector to start with. And again, particularly what direct electrification is difficult to achieve in these industries. Let's talk about, because since morning we are talking about cost. Like, okay, when you talk about green hydrogen, it comes with its own cost. And it's a journey. It will not happen in one day. It takes 2 years, 5 years, 10 years down the line. And the way the R&D can be done on various technology on the hydrogen storage side, electrolyzer side. But in this journey, you have to do a lot of analysis. You have to emulate, you have to simulate. Okay, if tomorrow hydrogen electrolyzers by cut down by this cost, how my techno-economics of the project will be happen. if the hydrogen storage will be cut down by this cost, how much my techno-economic of the project will be worked out. If renewable technology battery storages get much cheaper and cheaper. You have seen last couple of years, the battery cost was drawn down by 30 to 40%. So how my techno-economics of project will be changed. You need to do this analysis on continuous basis. You need to do a lot of modeling exercise where I think we as a company help the overall global industries, how these modeling and simulation, which can try to mimic your original operation without putting a project on ground. And you can see in the digital twin how these things works, and you can take a decision which can definitely reduce your business risk. Again, when I talk about the green hydrogen and ammonia, so what are the things we are typically look after when you are setting up the green hydrogen project? And when you say green hydrogen, if you want to run the electrolyzer, you have to use the green electricity. Green electricity is nothing but coming from the renewables. So what should be the right sizing of your solar? What should be right siting of your solar site? What should be right siting of your wind site? What is this? Is it battery storage makes more sense, or hydrogen storage making more sense? What kind of electrolyzer technology I should use so that my project economics can be best suited to deliver my hydrogen or deliver my ammonia? So these are the few pointers, which is like very key. It's not, you can manufacture the hydrogen, but is it feasible to transport the hydrogen? What kind of transport model I should use so that I can deliver the hydrogen at my end user? What kind of transport model I can use to deliver the ammonia at the delivery point of the industry? It can be a fertilizer industry. So these are the challenging questions when somebody is putting millions and billions of dollars in such kind of project. So you need to have some solid analysis, mathematical analysis. The lot of mind and thoughts and hundreds of scenario needs to be run. Then you come to a decision, informed decision, which can help you. Okay, is my solution optimal enough? Optimal. Okay. Many people talk about, okay, that much capacity, it could be 100 megawatt, 200 megawatt, 2 gigawatt, 50 megawatt, that much ton, but is mathematically optimal solutions, which need a lot of scenarios needs to run. So in my coming 10 minutes, 5 minutes time, I'll take one example, how you can model this by using advanced modeling software like Plexos. Traditionally, if you see, everybody is used to talk in silos. If somebody is manufacturing, generating electricity, it can be coal, it can be renewable, it can be hydro. So they just talk about that electricity, how it can be generated economically. Then you come to that is electron part. But when you come to the molecule part, they just know about molecule. So they just work in their silos. Okay, I am looking for hydrogen, I am looking for ammonia, how my chemical process will happen. And then the end of the transportation, which is, I think, very, very critical factor in hydrogen and ammonia scenario. How you can transport hydrogen. What is the mode of the transporting? Is it techno-economically viable or not? When you solve these things in the silos, it can't be an optimal solution. If you want to really get the global optimal solution, the best optimal solution, you have to integrate each and everything in one go, or maybe in one model, or where you have to think through it in one thought process. Okay, if I connect the electron with the molecule and finally transport to the end point, is my complete solution global optimum or not? So you have to integrate this. And to integrate, if you see, you need not to work in the silos. You have to integrate all stuff together, all physical asset together. Okay, this kind of busy slide, but if you have a traditional way of generating the electricity, then the renewable come into the place. Power to X can be hydrogen, ammonia. Then you have the gas industry. Till the time you don't connect all these things together, then you will not get the global optimal solutions. Where, as I think, de facto best tool in the market, we do this kind of modeling, run hundreds of scenario, and try to give you the informed decision before putting millions and $1 billion in your project. If I talk just from the green hydrogen perspective, if I see this puzzle, when you're talking about the green hydrogen, their input of electricity is coming from your renewable generators. It can be solar, wind, it can be pump hydro. Then again, hydrogen are you using to manufacture the derivatives? Can be ammonia, it can be green fuel. It may going back to the gas generator again to flame the fuel and again generate the electricity. So this is a complete cycle. And when you're investing this money, the two-way the modeling can help. Are you thinking about where when you are not putting up the project, you are planning your 30 years, 50 years down the line, the investment plan. Okay, what should be my levelized cost of hydrogen? What should be my levelized cost of ammonia? Is, is my the tariff cost optimal or not? And once you plan this, and when you put up your plant, like it can be hydrogen plant or ammonia plant or a complete cycle, electrolyzer, renewables and all, you need to go back and see whatever you planned and put the investment. Is my plant is running and giving that much of outcome or not? That's where the operational optimization come. Okay, tomorrow wind will not blow, then you have to do the uncertainty analysis, maybe run Monte Carlos, maybe run some different statistical analysis and see, okay, this thing I have to change tomorrow to get my production right. Those kind of analysis required a lot of advanced modeling and put a lot of data, do a lot of data crunching, and finally take a decision on the planning side as well as the operation side as well. This is just one example I am taking from one of the tender which Seki has came up, which has not gone forward yet as understand discussion. I am just taking the fight for fertilizer plant. If you see on your light, there's ammonia demand. So the typical input to this particular model to meet that ammonia demand and at the any fertilizer plant, what should be your total mix of your physical asset? Again, is optimally, which I am talking about. There is a transportation medium. Then again, if I start with, for meeting that ammonia demand, what should be the energy mix of power? How much solar, how much wind? Is it the battery? What kind of battery? Is 2C, 4C, 8C? What kind of electrolyzer, when you talk about what capacity of electrolyzer I need to meet that demand? What kind of ammonia plant of capacity I need it? How should I run the ammonia plant? What kind of transport model I should select so that my overall objective is to minimize overall NPV, considering from your generating electricity for meeting your ammonia demand. If you are changing your ammonia demand load profile, how my overall system will work? So these kind of analysis require a lot of data input, a lot of data crunching, running this thing in linear programming and mixed integer linear programming, and give you the, okay, what should be my minimum cost of overall project? So that thing is happen in Plexos very quickly. How does it happen? Like, okay, when we're dealing with the power side, okay, you have some input on your renewable power. It can be solar, it can be wind, it can be thermal. If you're talking about green, thermal is not the part, the pump hydro is there. And then while you're dealing with the renewable energy, you deal with a lot of uncertainty and you can quickly run the Monte Carlo and get the anyway. The typical, this is again the Plexos window, but what typical input is required when we are modeling this? This is typically how you represent the solar generator in Plexos. Since you are doing the techno-economic analysis, you have to put your variable cost, your capital cost, your solar profile as an input, and definitely your degradation factor. There are many boundary conditions which you are looking into the project. Those boundary condition goes as a constraint to the model. This is a typical solar profile. If you see on the 1 megawatt normalized factor, okay, this is 24 hours, but if you have a 15 minutes solar profile, you can do 15 minutes. And if you have a 1 minute or 1 second granular level of data, you can even put that is in a Plexos. Again, this is in the chart for how your solar profile looks like. Similarly, you need to represent the wind generator in the Plexos. Typical input is the same, but the major changes with the capital cost, your WACC, your variable cost, and again, the wind profile. How you represent the battery, which is very, very unique to the Plexos. Plexos try to mimic your battery operation for next 10 years, 12 years, and try to size the battery. And to represent the battery as a physical system, you see how many technical parameters are there. Their minimum SOC, initial SOC, your round trip efficiency, your capital cost, your degradation. All these factors goes into the input to the model. How to represent the electrolyzer. These are, again, to representing electrolyzer, you need to put the ramp up, ramp down efficiencies and all. Similarly, how you represent the ammonia plant in the Plexos. These are the property, these are the value you need to put into the model. And on transport side, okay, you have a voyage time, discharge time, maximum ship on the hour, maximum day, maximum volume. So these are the typical input required when you want to run the model in Plexos and try to get your minimum NPV of the overall project. Typical outcome when you run the model simulation, okay, this is the one very simple example on the deterministic scenario I'm taking. Don't go on the numbers. I'll just doing it. The typical outcome will be, okay, how much solar on the west side, how much wind on the wind side, how much BESS, what kind of BESS, what is the cost of the BESS, Okay, how much capacity of the electrolyzer will be required? What type of electrolyzer? These are the typical outcome, or maybe there are 100 outcome also come when you run the simulation. This is just in the chart I wanted to show how without putting a project, you can see in the software, in the model, if you are putting the project for next 25 years, if you run this project, how your generation profile looks like to meeting the electrolyzer load, which is in black in line if you see on the top, how much solar is generating, how much wind is generating, how the battery is operating. This is how you can see the battery operation. If you see non-solar hours, you can see there is generation in less. And then Flexos will throw you the result, okay, when to charge the battery, when to discharge the battery. It means when you're sizing the battery at the optimal level, it is considering its operation for next 10 years or 12 years till the time the battery operation is happen. Okay, this is again, if you're using the pump hydro, how pump hydro will be operate. This is again, these are the just number, but these kind of output you can get very quickly from daily basis, weekly basis, hourly basis, how much production of hydrogen is happening, how much production of ammonia is happening, how your transport and delivery is happening. Can I put the ammonia storage at the just below the before the fertilizer plant, or I need to put the ammonia storage just after the hydrogen plant? So all these answers can be done by, and the most important part, yeah. Another important part, okay, how your overall cost of the project looks like. So these are the typical outcome. You run the models, you get the analytics and everything. So this really helps when from the morning we are thinking about the cost, we are talking about the technology. There are so many unknowns when we are dealing with the $1 million of the project in the hydrogen and green hydrogen side. Man, you have to sit down, do the number crunching, run many scenarios, and you need a good tool to run those kind of things. So where we as an Energy Exemplar come into the place and help many countries, many companies around the globe. So hope this session is useful. It was very quick. It took 2 hours to do the detailed stuff, how these technologies are helping, but I am here till half a day next. You can come to me and ask any questions if you have it. I think time is up. I took little more than what is given to me. Thank you very much.